Hi, it's Chris here. So today I'm going to show you what our mini lightweight math optimized LLM looks like, and we've called it Mathw 1 for a lack of a better naming. And you can see it's only like 1.05 gigabytes in size. It's actually a 1.5 billion parameter model, even though it shows an LM Studio 7 billion. I don't know why. I've done something maybe to mess that up, or it doesn't pick it up, whatever. But you can see it's a very small model. It's about a gig in size. It's got 4096 context length, and we're not going to use GPU offload. And you can see we're using about 1.2 gigabytes of RAM. If we optimize it for the GPU offload, it doesn't really make a big difference, slight difference, but not that much. So this means you'd be able to run this model locally like I'm doing here using tools like Ollama or LM Studio, and you'll be able to run that on pretty much any computer, even your phone perhaps. Okay, so we've got a couple of math problems here on the right-hand side in that spreadsheet. So we've got the problems, the problem definition, and then we've got the correct answer that we're looking for. And what we'll do is we'll ask 10 reasonably difficult questions that we expect a advanced model such as O3 from OpenAI or a model from DeepSeek like the R1 reasoning model should be able to solve. But keep in mind, those models are 671 plus billion parameters in size. They're massive. They require huge resources and infrastructure for inference, and you won't be able to run them locally unless you use the distilled model. So what we've done here, and of course those distilled models are not as efficient and smart. So what we've done here is we've taken a basic model, a base model, a 1.5 billion parameter base model, and we've trained it on a huge amount of mathematical problems with answers. And now we're trying to test and see whether it can actually do a little bit of complex math solving. And as we're running through here, you can see we're running through the questions and it's answering them really well. It's actually doing really well so far. So we'll head on to the next one. So this one is pattern finding, and we can see the reasoning process that's happening here. So it's breaking down the problem. It is using a thought process, and then it is trying to solve the problem and providing responses and answers when it does so. So again, we've got another correct answer there. We'll head over to the next one, and we'll see how this one performs. Okay, so we can actually see it's got it wrong here. So we're going to try and run it again and see if it would provide a more accurate answer. So it, for the second time, didn't. So we're giving that one a score of 0. So far, we've got 4 out of 5 questions correct. Now we're continuing with the process, and I'll speed this up a little bit and let's see how we go. Okay, so we're running through the remainder of the questions. And we can see there on the screen, it's actually solving pretty complex problems, and it's done an exceptional job of this. So I'm quite impressed. There's still a lot more training to be done, but it's doing a pretty good job. So again, we've got another correct answer there. On this last one, it did provide the correct answer, but not as I expected. So I gave it half a point there. And overall, that gives us a result there of 85%. So out of the 10 questions, it did really, really well. Now we've been training another model on a different base model. So this one I call DS Mini, and we'll just run some of these questions where this one failed in the other one and see how that performs. And again, this is using the same math data set. It's just a different model, but you can see there from the GPU usage, or the, sorry, it's not a GPU. We're not using the GPU offloading. From the normal RAM usage, this one is about double. That's because the context length of this base model is much larger. It can actually handle up to 131,000 tokens. So that requires a bit more memory. You can, of course, set that smaller. So if we want to run that again at about a gigabyte of RAM, we can just set the parameters to a maximum token. But anyway, context length. So, but anyway, this one also got this wrong. So yeah, it does really well, but there's still, for the high level stuff, a little bit more fine tuning that needs to be done. Now, just by the way, we thought we'd try some additional tests here. And what I did is I went to DeepSeek and I said, generate a math problem that normal LLMs would struggle to solve. And you can see it's been thinking there for quite a long time. And it came up with this problem here. So it wants us to find the smallest prime number following a bunch of parameters. So I said, okay, just convert this into normal text so I can copy and paste that into my other LLM and give it a shot. Now, by the way, I did put this into the O3 Mini chat as well, and it obviously was able to solve it properly. And you can see we're loading the model here. This is the Mathw model again. This time we left the GPU offloading as it was, and we'll run this through to solve. And it is quite remarkable. It shows us step by step. It wasn't trained on this specific problem. It was generated on the fly by DeepSeek. But that's no problem for the mini Mathw. You can see it's actually running through and solving it. And while we're doing that, not that it's a fair race because I started much later on DeepSeek, but we'll run the same problem in a new chat in DeepSeek and see if it can solve its own problem, just to be sure. On the left, we can see our model running locally in LM Studio, completely disconnected from the internet, of course, but we can see it's running pretty well there, and it's starting to converge to an answer. And once we get the result there, I think the result we were looking for was 5. So there we go. So it solved it and it's found the solution there and it's got a result of 5. Okay, and then we'll speed up the recording a little bit so you don't have to watch paint dry, but we are waiting for DeepSeek to get to the same conclusion. We can already tell that it's taking much longer than it took our mini math wizard to get to the correct answer. But once it does, we'll see that the answers are the same, and it is in fact correct. The only exception is we've done it with a 1.5 billion parameter model, while DeepSeek R1 that you see here is running on 671 billion parameters. So that's quite fantastic. Now, it's worth saying that our model is really good at math, but it's probably not good at everything else, but it's still really great progress. Okay, see you soon. Bye.